But wait a minute. Whoever said that the planet is the good inertial frame of reference? Remember that? That's all relative. So it is just as accurate to say that, from the perspective of the twin on the spaceship, that the entire universe spontaneously shoots itself at near light speed in the other direction. And then it all turns around and comes back. Which, intuitively we realize if everything in an environment, if it's all going in one direction, it's probably because I am going in that direction, right? But there's no real reason to take this one twin versus the other. I heard some other thing somewhere that the real reason they end up different ages is the point of turning around, and that acceleration throws things off, or something. That still doesn't quite explain it, though, because from the perspective of the traveling twin, it is his twin that is traveling. And the planet, the whole planet that he's leaving, that planet is shooting away at near light speed, and then it accelerates, turns around, and comes back. As far as he knows. To make that clearer, imagine there are two twins in two spaceships in the middle of nowhere, right? And one of them shoots off at light speed, but let's say neither of them know which. Let's say they're both sitting in a locked thing and there's no windows or whatever, right? So each of them thinks to himself, now, and they both have a distance meter thing, so they know the distance between each other, but nothing else. So the twin is sitting in this thing, and he goes, okay, now either I'm moving away from him at near light speed, looking at the distanceometer, whatever. Either I am moving away at near light speed, and then I come back and I go see him, in which case I will be young and he will be old, or he is moving away at near light speed, and then he comes back, in which case he will be young and I will be old. And the both of them are thinking this. And this almost reminds me of quantum physics, wherein we really have no idea, as far as I can tell, and I don't really know much about this, but it's like we don't even know which twin is young and which twin is old until we open up the spaceships and look inside and observe, and then it becomes real. Maybe. Seriously. If everything's relative, who's to say which of them is moved near light speed? Who's to say? Furthermore, considering all the rotations of all the, like, we're going around the sun's going around like the other things. It's like it's in a star cluster, and the whole galaxy is turning, and then there's some other galaxy. Might there be some other planet somewhere in the cosmos that, from our perspective, is moving at light speed? Like, imagine that we're, say, on the sun, and we're rotating this way, so we have like velocity in this direction, and then let's say that the sun, as a part of its gravitational clusters or whatever, is also kind of moving this way, so that kind of adds on. Imagine the whole galaxy is spinning this way at this particular moment, and imagine, I don't know, the freaking supercluster is all, but like, if everything, little things are adding up, and then something else is doing exactly the opposite thing, it's all rather, improbable, I guess, but it might seem from our perspective that other planet is moving away from us at nearly the speed of light, and that therefore time is going very slow for them, which would almost explain that one crazy Fermi paradox. Which, wouldn't that be weird? The solution to the Fermi paradox is that everyone else is developing slower because they're moving near light speed. That doesn't make much sense. Particularly the improbability of two planets that happen to be going apart from each other at near light speed, but still. And then, if there were people on this other planet, they would look at us and they would say, aha, time is moving slow for them. And neither of us have any objective measurement to find out, right? Because beforehand, we could, measure speed by some sort of measuring tool, like, a bullet or something. Let's say this guy, takes off in his spaceship and you fire a bullet at the same time, and if we know the speed of the bullet, the guy can compare and be like, aha, this is how fast. Well, I guess, okay, you can kind of still do that. But my deal is, like, if you compare it to light, then it's the same either way. There's another thing. Like, let's say we shoot off there's a light gun, you know, and it shoots a beam of light at the same time a spaceship leaves. Or say the spaceship was already going, so it accelerates to near light speed, and then, pew! They all both go off at the same time, right? So then, I'm gonna see you come by. If I'm holding the gun, right? The spaceship comes by at near light speed. I shoot the gun, hopefully in a precisely straight angle, right? And then both of them leave at near light speed, right? Or the one leaves at near light speed, the other is light. It leaves at actual light speed. So, let's say the guy, you know, does this. Let's say he's traveling at like 0.9 light speed, right? And he does this he goes for a year. So, obviously, from my perspective, the light's moving at light speed, he's moving at 0.9 light speed. In a year, the light will have gone 1 light year, he will have gone 0.9 light years. There should be a gap of 0.1 light years between them. Between, you know, where the spaceship got and where the farthest edge of that beam of light is. But from the other guy's perspective, light is moving at light speed, from his perspective. Now, he knows that he has traveled 0.9 light years, right? But from his perspective, the light has been moving not just light speed compared to his own 0.9 light speed, it's been moving light speed from his perspective. So in a year's time, it should be a light year ahead of him, which makes it a total distance of 1.9 light years? Now, okay, there's a fallacy in there. Because if he's moving at 0.9 light speed, he will experience time dilation. So, if time dilates for him, then, let's see, a year ends too soon. If we're going by the gun guy's measurement of what a year is. Okay? So the year ends early for him, so he ends early. You know, he'll be like, it's only been a couple of months. And the other guy's like, what are you talking about? It's been a year. So the year ends early for him, so he stops what he believes to be short. So I don't even know how much time dilation he would suffer. But he stops, and it's 0.9 light years traveled, but he thinks he's been traveling at 0.9 light speed for less than a year. So he's traveled less than that distance from his perspective. Now, how much distance has he traveled? Has he...